Hey guys, welcome back to the channel. So we are doing the sliding window list. I didn't realize we have completed quite a few medium level problems. So going to the next one, it's 718. So we put 718 maximum length of repeated subarray. The prompt statement is given two integers array of nums of 1 and nums of like nums 1 nums 2 two arrays. Return the maximum length of a subarray that appears in both arrays. Return the maximum length of a subarray. Oh, great. So, I think 3 to 1 here. So, answer should be 3. The repeated subarray with the maximum length is 3 to 1. Fine. So, it's 5 since all of them are repeating. So, the length of the two arrays will be between 1 and 1000, and the elements will be between 0 and 100. So, guys, this is one new kind of problem along the line. So let's see how we will be doing this. So how are we comparing this? 3 2 1. Possible that a person both are a great. Maybe we can do the elimination stuff, like we can eliminate, we can start with 1 and 1 exists in it, 2 exists in it, 3 also does, but 4 and 7 does not, so we can remove 4 and 7. So right, what should be we doing? 1 2. So initially 1, we checking 1 and 1 2. There is no 1 2, so from 2 3 we are going to check from 2 3, and there is no 2 3 either. And 3 2, there is 3 2, so we shall increase it to another point, and 3 2 1. Since we have reached to the last, I guess we should stop here. Right, so what's our approach? We are going through the first array for nums of 1, I mean nums 1, and it didn't that no, it didn't say the both arrays will be of same length. Let's try adding a case where we'll encounter two different lengthed subarrays like this, and see if it says wrong type of input. So guys, we can expect arrays of different sizes. So let's see. No, so why? Let's keep it L1 and R1. Of nums 2 nums 2 4. So what should we think we should do? We have to check if one does exist. So one does exist. So the length will be 1 currently. So let's keep sir equals to 0. Let's from so if we find on if answer So normal cell plus one. So if now one, it will be one. Next, we're increasing with plus one. Then we won't find it here. That's right. That's right. So, and we are not incrementing R2 here. And R2 is less than on the boundary. Flums of R. So, so answer is 1 plus 1. Answer 1. So let's try run in our mind. Essentially answer will be 0. We will be checking one size elements. Let's try this. Well, but I am not sure it will work, but let's just try it. There's no bad trying things, right? Think, sorry guys, network error. Let's do now. All right. Mhm. 0, 1, and 0. So let's see what's happening here. So initially L1 will be 0. Let's check, what are they comparing. Great. This is what happening, guys. Three, two, 167. It's not working the way we assumed, guys. So L2 will be 0 and R2 will be answer. L1 will be 0 and R1 will be 0 too. No match found. We found a match here, so the answer is 1 now. So now we have to check 0, 1. So since the answer is 1 now, we will be checking arrays of size 2. So alt 2 will be like this: 3, 2, 2, 1, 4, 7. First, 1. Let's stop this and see how R1 and L1 are changing. Also answer. So Answer answer is 0. So this is causing a bit of issue. So initially the answer is 0. L2 and R2 is also 0. 0 0. 2 1. So this should not be correct. So 0 1 it is 0 1. Should be 0 2. 0. How did R1 become 1 though? We're starting from this. Okay, guys. I got it. I got the issue. This is a silly mistake. Let's see now. Oh, since our logic is working fine. Great guys, it seems we are improving bit by bit every day. So let's try submitting the answer and discuss the intuition again. Good. Guys, it seems the answer, like, we achieved the answer, but it's not optimal, I guess. But the space complexity is, it's fine. Since the, like, we are finding bar far to right from where we are, it seems there is optimal solution which increases the time complex, like space complexity. So since we have achieved uh, the best space, like the here the time complexity will be order of n square. Let's let's try analyzing the space complexity, I mean time complexity. The order of n square. Wait. Order of n into m into minimum of n command. So is it hmm, order of n cube? Let's see. But how is it order of n cube? It's order of n square, right? Let's ask ChatGPT. Since lately ChatGPT is taking so much time to load, and oh, let's break it down and let's see if we can find any more insights. Our motto is to learn as much as possible from the resource we have. So the test cases are way too low, but I believe they have covered all the cases. So by the time it gives us answer, we will discuss the intuition. So the intuition is, as I said before, so initially we'll be taking a slide of size 1 and we check we will be sliding window of size 1 throughout terms of 2, and if we find any element that matches it, then we'll be returning uh, what do we call, then we will be recording uh, we have a element that matches in both. So now the answer is 1, and since the answer is 1, we are considering this, and we are keeping L1 equals to 0, and we will be moving to the next one. So now we will be sliding a window of size 2. So 3 2 we didn't find it, 2 1 we didn't find it, 1 4 we didn't find it, and 4 7 we didn't find it. So we didn't find a match. Now we are at, like, we are incrementing L to 2, and now we will be checking. Like, since we have found since we have found uh, we have element of size 1, I think we should not check again the element of size 1, rather we should If we increase L to plus one, right guys? If we even though if we increase L to plus one, now R1 also increases. Now we'll be checking window size 2 3, which gives us like we check 3 2 does not exist, 1 no, 1 4 no, and 7 4 7 no. So 3 2. Now we will be checking windows of size 2. That should it should match 3 2. So 3 2 it does match guys. So we will not increase, we'll be keeping L1 here only, and we'll be incrementing R1 to 3 to 1. Now we'll be checking uh, windows of size 3. So 1 2 3. So we did find it, and we reached the end of the array, so we are returning the answer. This our current code is correct but inefficient and can be significantly optimized. Your code, you are fixing a window L1 increasing R1. For each such window, sliding a window is the same length over now to comparing Subarray was missing. If a match is found, you update the result. Outer loop runs order of n times. Inner loop slides over first order of m times. Okay. Subarray comparison. Oh, where only Subarray length. Total worst case the order of n into m into l. This is an efficient. Okay, so that's why it's order of n into m into l. Okay. Each slice and creates a new temporary space. Okay. All space equals to out of it. You can optimize this using dynamic programming. How the understand. So what is you do? Dynamic with bottom table. So we are like we are not familiar with dynamic programming, but it's not bad if we check it. So we are adding, we are creating a dynamic array of size order of n into m here, and for example we are iterating in a reverse order for generating the timelines, and same goes for array b. If you have I equal to b of k, then I plus I didn't understand this. Oh, as it seems it went to a two-dimensional array. I don't think it should went to a two-dimensional array, and the comparison is uh, as of now I couldn't able to comprehend, but we sure will understand it, I guess.